So the next two questions that we have, question number 9 and 10, both questions are based on your normal distribution, also known as your Z distribution, right? Before moving to solving these sums, I will just like to explain to you what normal distribution actually is. See, you have seen the normal distribution curve. Normal distribution curve looks like this, also known as the bell curve, right? You must have seen the correct diagram. See, it is symmetric about the y-axis. See, I will just try to explain to you why normal distribution, how normal distribution. First thing first, normal distributions occur naturally, right? When I say normal distributions occur naturally, what does this mean? If I take marks of all the students of Vishwaniketan, right, of any institute for that matter, let us say that there are nearly 2000 students in our college. There are more actually, but let us say approximately 2000 students in our college. And if we take the CET marks of all these 2000 students, or we take the 10th standard marks of all these 2000 students and we put it, for example, there is some student who has got 56%, there is some student who has got 70%, there is some student who has got 90%, right, 95%, like this. And if I put these marks on this axis, I put the marks on the x-axis, and I put the frequency on the y-axis. Frequency means what? Let us say 56, 3 students got 56, 10 students got 70, 15 students got 90, 4 students got 95. So this is what? This is the frequency. If I put the frequency on the y-axis and marks on the x-axis, the curve that I am going to get is going to be a normally distributed curve, right? This is going to happen naturally. It is not forced. This is also seen in what? This is also seen in IQ of people. This is also seen in height of people. Okay, height of males and females separately. Yeah? If you take height of males and you take height of females separately, then you will get these curves. If you take them together, you won't get a normal distribution curve, right? If you take weight, if you take all such naturally occurring things in this, you will always get this normal distribution curve. Okay, so this occurs naturally. Whenever we are talking about a normal distribution curve, there are always two important things. What are those two important things? Those two important things are mean and variance. What is mean? Mean is this mean value. Mean is this central value. Okay, the central value of your normal distribution. And what is variance? Variance is the variation from the mean, right? Variance is what? Variance is the variation from the mean. Okay, I'm not going into the technical details, what, why this, how this, what is the formula. Okay, because this much is enough for us. For mean, what is the symbol that we use? For the mean of the population we use mu, for mean of the sample we use m. Okay, it is not equal always. These are the symbols that we use. This is what we use for population, and this is what we use for sample. What is population? Population is going to be all the people, right? All the people of Vishwaniketan is going to be population. So I won't be able to get marks of all the students, right? Because I don't know them. So what I will do, I will get only the marks of the mechanical department. So that is going to be what? That is going to be my sample. This is going to be my population of 2000. Let us say 200 are our mechanical students. So our sample is going to be 200, right? And what is variance? Variance for population is given by sigma square, variance for sample is given by s square, where sigma is what? Sigma is, or sigma or s is what? It is your standard deviation, right? So these are the important terms that you have to remember. What are the two important terms in normal distribution that you have to remember? One is mean, and second is either you can remember standard deviation or you can remember variance. Remember, variance is equal to standard deviation square. Okay, or standard deviation is equal to square root of variance. However you want to remember it, but just remember these two things, right? Now see, this is normal distribution. If we take a normal distribution, let us say we take normal distribution of human IQ. So the normal distribution of human IQ says that the mean is about 100. So this is going to be my mean, right? But if I am going to talk about the distribution of height, then what is going to happen? Then the mean is going to be something different. We can say the mean height of Indians is what? Let us say 5 foot 8 inches. Okay, I don't know what it is really, but let us say that the mean height of an Indian is 5 foot 8 inches, right? So here the mean is different, here the mean is different. Then how are we going to know what is over here, what is over here, what is the value over here, what is the value over here? So for this, what they have done, they have created a standard normal distribution. What these people have done, what the statisticians have done, they have created a standard normal distribution, and we can convert any distribution into this standard normal distribution, right? How we can convert, I will just tell you the formula, but we can convert any normal distribution into our standard normal distribution. So in case of standard normal distribution, what is the mean? In case of standard normal distribution, the mean is 0. And what is your standard deviation? Your standard deviation is 1. Okay, so these are the values. Mean is 0, standard deviation is 1, or you can also say variance is 1, because 1 square is 1, right? This is your standard normal distribution. And what is the formula to convert your normal distribution into standard normal distribution? The formula is given by Z is equal to x minus m upon sigma, where m is your mean and sigma is your standard deviation. I will explain what x is, what z is in a few minutes. When we solve the sum, you will understand. But this is the formula by which we can convert any normal distribution. We can convert any normal distribution into standard normal distribution. Okay, so this is what we are going to do in the next two sums, right? So let us start. We will start with question number 9, I think. Yes, question number 9. What have they given us? The diameters of can tops produced by a machine are normally distributed. Right? See, they are normally distributed with a mean of 3 centimeter. What is the mean? Mean is 3 centimeter. So we can write it over here. Mean is equal to m is equal to 3 centimeter. Next thing what they have given us, and standard deviation of 0.05 centimeter. So they have given us what? They have given us sigma, which is what? Standard deviation, which is how much? 0.05 centimeter, right? What are they asking us? They are asking us what is the probability of finding a can top with a diameter between 2.90 and 3.05 centimeter. So what is the range that they want? From 2.90 centimeter to 3.05 centimeter. So our can diameter should be between this. But if you look at the standard normal distribution table that we have, for example, I will show you over here the standard normal distribution table that we have, right? It is also known as Z table. See, in this case, the mean is 0 and the standard deviation is 1. But in our case, in our question, what is the mean? In our question, the mean is 3 centimeter. So we cannot directly use our standard table. We will have to convert our normal distribution into standard normal distribution, right? So see, what is the range that they have given us? From 2.90 centimeter to 3.05 centimeter. So let us call this x1 is equal to 2.90 centimeter and x2 as 3.05 centimeter, right? So we can draw an approximate graph over here, right? So mean is what? Mean is 3 centimeter. So 2.9 centimeter is going to be somewhere around here, and 3.05 centimeter is going to be somewhere around here. So what we have to find? We have to find out the area of this. This is going to be the probability of finding the can top between 2.9 centimeter and 3.05 centimeter. We have to find out this much area. The total area under the curve is 1. The total area under the normally distributed curve is 1. So if the total area under the normally distributed curve is 1 and this curve is symmetric about the y-axis. When I say symmetric about the y-axis, it means what? It is same over here also, same over here also. Therefore, this much area that is to the right of the y-axis is 0.5 and this area to the left of the y-axis is also 0.5. So both are what? Both are 0.5, 0.5 and total area is what? Total area is 1. Right? You have to remember these two things. That the total area under the curve is 1. To the right of y-axis it is 0.5. To the left of y-axis it is 0.5. So now coming back to this question, we have to convert our normal distribution into the standard normal distribution. So how can we convert? We know x1 and x2. So can we find out z1? So z1 is what? Z1 is going to be what? x1 minus m upon sigma, right? So we can put x1 value. X1 is 2.9. What is m? M is 3. What is sigma? 0.05. So it comes out to be what? Minus 0.1 divided by 0.05, which comes out to be minus 2. So Z1 is minus 2. Similarly, what is Z2 going to be? Z2 is going to be x2 minus m upon sigma. So x2 is going to be 3.05 minus 3 divided by 0.05. So it will come out to be what? 0.05 divided by 0.05, which will be what? Which will be 1. So we have to find out, if they ask us to find out the x value between 2.9 to 3.05, we have to find out the probability of z between -2 and 1. Now, how can we find out the probability of -2 and 1? See, whenever we have this graph, this is at the center is 0 in standard normal distribution. So we have to find out area till here -2 and we have to find out area till here, which is 1. So from 0 to -2, it is symmetric about the y-axis. No? Normal distribution is symmetric about the y-axis. So what we have to find out? We have to find out probability of z between -2 to 0 and we have to find out probability of z between 0 and 1, right? So from -2 to 1, if you have to find out the complete, it is divided into two parts. First we have to find out -2 to 0, then we have to find out from 0 to 1. But what do we know? That the normal distribution curve is symmetric. So area between 0 and -2 is same as area between 0 and 2, right? So to find out the area, we have to find out the area between 0 and 2 and then add to that the area between 0 and 1. So what is the area between 0 and 2? So to find out the area between 0 and 2, we will go over here and find out 2. Z value 2. See, Z value 2 is over here. What is the value? 0.4772. So this is the value that we are interested in, 0.4772. You write over here 0.4772. What is the area between 0 and 1? Area between 0 and 1, over here 1 we have. Area is what? 0.3413. Area is 0.3413. So what is the total area? Total area is 5, 8, 11, 7, 8. 0.8185. So this is going to be the probability of finding a can diameter between 2.9 and 3.05 centimeter. So what is the probability? 0.8185, which is what? 81.85%. Right? So this was the probability of finding a can of diameter 2.9 to 3.05. So that was what? That was our question number 9. Similar to question number 9, we have question number 10. So let us look at question number 10. What are they telling in question number 10? A radar unit is used to measure speeds of cars on a motorway. The speeds are normally distributed. Again, the speeds are what? Normally distributed with mean of 90 km per hour. What is the mean? Mean is 90 km per hour. Okay. And what is the next thing they have told us? Standard deviation of 10 kilometer per hour. Standard deviation of 10 kilometer per hour. Right? What are they telling us? What is the probability that a car picked at random is traveling at more than 100 kilometer per hour? So the car has to travel at more than 100 kilometer per hour. So if this is our normal distribution, over here we have 90 kilometer per hour, over here we have 100 kilometer per hour. We have to find out the probability of the car traveling faster than 100 kilometer per hour. Means we have to find out this area, right? This is the area that we have to find out. Now see, I had told you previously what is the total area to the right side of the y-axis. What is this total area? This total area is 0.5, right? This total area is 0.5. So if we want to find out this black area, if we want to find out this black area, what is that we are going to have to do? We will have to first find out this entire red area. We will have to first find out this red area. From that red area, we will have to subtract this blue area. When we subtract this blue area from this red area, whatever the area that we are going to get is the area that we are interested in. It is the speed greater than 100 kilometer per hour. Okay, this is going to be the probability of a car going faster than 100 kilometer per hour. So we have to find out this area, right? Here we have 90, here we have 100. This is what? This is our normal distribution. But if we go to this table, over here there is no 90, no 100, right? Here we have 1, 1.1, 1.2. So how are we going to find out what this value is? We will have to convert our normal distribution table into standard normal distribution table, right? So how to convert it into standard normal distribution table? We have our formula, right? So in this question, our x1 is going to be what? X1 is going to be 100, right? Because we have to find out the probability of a car traveling more than 100 kilometer per hour. So we can write over here z1 is equal to x1 minus m upon sigma. So x1 is what? 100, m is what? 90, sigma is what? 10. 100 minus 90 divided by 10 is 10 divided by 10, 1. So z1 is 1. So we have to find out the probability of z greater than 1. We have to do what? We have to find out the probability of z greater than 1. So if we have to find out the probability of x greater than 100, it means we have to find out the probability of z greater than 1, which means what? Which means 0.5 minus probability of z being between 0 and 1. Right? This whole area is 0.5, na? Red area is 0.5. From this red area, we have to subtract this blue wala area, which is this, right? So 0.5 minus what? It is still 1, na? So if we will go over here, we will check what is the value for 1. 0.3413. So 0.5 minus 0.3413, which is what? 0.1587, or which can be written as 15.87%, right? So this is how you solve normal distribution or Z table sums, right? So this completes our question number 9 and 10.